In this question, we've got a particle moving along the x-axis with constant acceleration. So if you look at the graph for this, acceleration time is just going to be a constant. Well, we know the area under an acceleration time graph just gives us velocity because we've got meters per second squared multiplied by seconds. Effectively, that gives us meters per second. So we can say the velocity equals the integration of a dt. A is constant, so we get v equals at plus our constant of integration. Now we need to find out that constant of integration, but we know when t equals 0, v equals 0, we're given that in the question, so our constant of integration is 0, and we conclude that v equals at. Similarly, if we look at a velocity time graph, we can see we've got an initial velocity of 0, we've got constant acceleration. So the area under our velocity time graph is just the displacement. So very similarly, we can say our displacement equals the integral of v dt, or we know what v is. V is just at. So our displacement is the integral of at dt. A is just a constant, so we're just really integrating that t there, and we get s equals at squared over 2 plus c, our constant of integration. We're given some initial conditions. When t equals 0, s equals x. So our constant of integration is x, and we get s equals half at squared plus x as required.